Alright guys, well thanks for joining us today after our week off last week for the 4th of July. So I'm Chrissy, I'm one of the console operators at the planetarium on campus, and I'm also a mechanical engineering student at UNT. So today I'm going to be giving a tour of some of the constellations and other things that we can find in this week's sky. So our moderator is going to be Oliver, and then he's going to provide a link in the comments for the software that I have pulled up right here, Stellarium, and then you can download it for free if you're interested. So the shows that we're doing are every Saturday at 2 p.m. and then after I go through my talk, we're going to be doing a Q&A. So if you have any questions, just put them in the comments and then Oliver will give them to me. And then since these shows are free, since we can't be in the planetarium, we've lost a lot of our income. I mean, pretty much all of it. So we really appreciate any donations to the Sky Theater Fund that you can give, and Oliver's going to put a link for that in the comments as well. So we're still doing our little thing. We're giving away meteorites for people who donate $50 or more. So if you've already donated, thank you so much. We really appreciate it. And we're getting ready to send out the first round for the people that did donate. But we still have like 10 or so left. So if you're interested, do that before we run out. But yeah, let me just go ahead and get started. Alright, so if you do download Stellarium, the first thing that you're going to want to do is notice this panel on the left. So we have like the location window. I have it set to Denton. Actually in Vermont visiting my parents right now, but the planetarium's in Denton, so I did that. But then we have the date and time window here. So I do have it set for today, and then it's in military time, so just subtract 12. So this is like 10 p.m. Yeah. Okay, so the first thing that you want to do whenever you go outside to stargaze is going to be to orient yourself, since you don't have these big red letters outside. So the easiest way to do that is going to be by finding the North Star. So you're going to be looking for this guy right here, the Big Dipper. And the Big Dipper is actually not a constellation, it's an asterism, so that just means that it's a recognizable group of stars. So the Big Dipper is right here, but it's part of Ursa Major, so that's all of this over here. But if we're just looking at the Big Dipper, you can go across from the handle here to these two stars, and they're going to lead us over here to the North Star. And the North Star is part of the Little Dipper, which is also an asterism, so it's part of Ursa Minor. So that means Little Bear in Latin. So we have Big Bear and Little Bear. And then the Big Dipper is starting to get a little lower on the horizon. So if you can't see it, like if it's too low, you can also use Cassiopeia over here, which just looks like a W or an M in the sky, and it just kind of opens up to the North Star. All these stars kind of in between in the Little Dipper are really hard to see. So if you look up in the sky and you see a dipper, it's almost definitely going to be the Big Dipper, unless you're pretty far out in the country. Yeah. So if we go down a little bit, I'm going to have to get rid of the ground here. But if we go down under the Big Dipper, we can find this star right here. Well, let me click on it. Okay. So this is Capella. So it might seem kind of weird that I'm pointing it out when it's below the horizon. But there's going to be a comet, Neowise. It's 2020's first naked eye comet, so you can see it without binoculars or a telescope or anything. And it's going to be near Capella. So it's going to be out like super early in the morning or late at night if you're going to be up super late, closer to like 45 minutes before sunrise. And then pretty soon, around the 16th, you're going to start to see it like just after sunset. And actually, I'll go forward a little bit to the 16th. So it's going to be like closer down here in the constellation of Lynx. Let me bring up those labels. Yeah, so it's going to be closer to like this area. Yeah, so that comet Neowise, it's going to be at its closest point to Earth on the evening of July 22nd. So on that day, it's only going to be 64.3 million miles away. So pretty close. But like I was saying, from like today to July 13th, it's going to be easiest to see like just before sunrise, so like 5 in the morning or so. But then after that, like July 14th to the 19th, you're going to be able to see it just after sunset. And like I said, you can't see it with the naked eye, but if you do have binoculars, it's going to be a lot easier to see, especially like if there's thin clouds or, you know, any haze can make it a lot harder to see. So let me just go back to today. All right, let me bring the ground back as well. All right, so from Ursa Major, so we can go back and use Ursa Major again. We can use the handle and we can make an arc to Arcturus. Arcturus is in the constellation of Boötis. So like I was saying, Ursa Major and Ursa Minor are the Big Bear and Little Bear, while Boötis is the Bear Watcher or Bear Guardian. So he's right there. Arcturus is a really large aging star. It's like 110 times brighter than our sun. So if we put it in our solar system, it's quite a bit bigger too. It would reach about 1/4 of the way to Mercury. So it's quite a bit bigger. And then over here, a little east of the circumpolar region, we have the summer triangle. It's going to be pretty prominent over here. So the summer triangle just connects the 3 brightest stars in these 3 different constellations. So it's going to be Lyra, the harp, Cygnus, the swan, and then Aquila, the eagle. So it's just right here, connecting these 3 stars. And then Cygnus, like I said, it's the swan, but it's also known as the Northern Cross. And then Vega is going to be the brightest star in the sky, so it's going to be super easy to see. All right, and so let's make our way to the southern sky. All right, so I'm going to go ahead and go to sky and viewing options, and I'm just going to bring up the ecliptic. So the ecliptic is just the path that the sun follows, but because of that, the moon and the planets are all going to be either on this line or really close to it. But then we also have all the constellations that are on that line are called the zodiacal constellations. So one of those is Scorpius, and then the brightest star in that constellation is Antares. It's got like a reddish hue to it. It's super easy to find, the heart of the scorpion. But Scorpius is really easy to see because you just have to look for this hook shape right here. And then just to the left of Scorpius, we have Sagittarius. Super easy to see by this teapot kind of shape it's got going on. So bring that one up as well. And then just above Sagittarius, if we zoom in here a little bit, we'll see this group of stars right here. So this is M24. Actually, let me just look this up so we can get, there we go. So it's the small Sagittarius star cloud. So that actually is visible to the naked eye under good conditions. So up here in Stellarium, when you click on something, you can see the magnitude. So it's kind of like golf, like the lower the magnitude, the better, the lower the number. So anything below a 6 you can see with the naked eye, as long as it's clear, like there's no clouds covering it or anything. But then anything above that, you'll need either like binoculars or a telescope or something else, depending on how dim it is. But yeah, so So this is a 4.6, so it is under 6. So you will be able to see it with the naked eye, but definitely with binoculars or a small telescope, it would be a lot easier to spot, and you'd be able to see more detail. So that guy was discovered in 1764, so a long time ago. And even though it's called star cloud, it's not actually a star cloud, galaxy, nebula, or even a star cluster. It's just a gap in the dark plane of the Milky Way. So there's just less light present, and that lets us see all the way to the Sagittarius spiral arm. So that's what you're seeing here. And then not anything you can see, but I just thought it was cool. So Friday the 17th is going to be the 45th anniversary of the Apollo-Soyuz link-up in Earth orbit. So that was like the first international space mission. So in 1975, 3 American astronauts left in an Apollo capsule, and then 2 Soviet cosmonauts left in a Soyuz spacecraft. So the Soyuz spacecraft docked with the Apollo capsule, and the 2 crews met up in space. So I thought that was super cute. And then if we zoom out a bit here, so on this line close to Sagittarius are going to be Jupiter and Saturn. They're going to be super easy to see. Jupiter is really bright. As you can see, the magnitude is negative 2.75, so it's pretty bright. Just zoom in a little bit. So you'll notice when I zoom in that you can see some of the moons too. So the 4 closest moons, Io, Europa, Ganymede, and Callisto, are pretty easy to see. I'm honestly not sure if you can see them with the naked eye. I haven't been able to, but maybe if you're farther out, it might be possible. Because their magnitude is below 6, like just barely. But definitely with binoculars, you'd be able to see them. So Jupiter is the largest planet in our solar system. You could fit over 1,000 Earths in it, or you could fit the rest of the planets with room to spare. So even Saturn is quite a bit smaller. I hear a lot of people say that like Jupiter is a failed star, like if it was just a little bit bigger it could have been a star, but that's actually not true. So Jupiter's mass is about 1/1000th the mass of the Sun, and to become a star, it would have had to be a 12th the mass of the Sun. So you'd need like 80 more Jupiters. So it would have had to been quite a bit bigger, and it would have taken a lot to accumulate that much mass. So it wasn't, unfortunately. Well, I mean, it's good for us because we definitely wouldn't be here if Jupiter had become a star. And then, as we know, Jupiter is a gas giant, so it doesn't have a solid surface. So like Mercury, Venus, Earth, Mars, those are all the terrestrial inner planets, and so those have a solid surface and rocky core. So like on Jupiter, the farther down you go, the gases slowly become liquid. And then Jupiter, if I zoom in a little bit more, here we go. You can see that its atmosphere is banded. So, we always see these pictures of Jupiter with like the different color bands. And that's just because like these lighter zones right here, these are the zones, and then the darker ones are called belts. And so they're just different abundances of hydrogen and helium, and they're also moving in opposite directions. So that causes a lot of storms. Just like the Great Red Spot. It's not popping up right now, it must be on the other side. But the Great Red Spot has been there since Galileo first saw Jupiter in the late 17th century. So it's been around for a long time, over 400 years. And it used to be about 3.5 to 4 Earths wide, but it's getting smaller now. That's the first time that we've seen it get smaller since we've been watching it for, so long. So it's only about 1.5 Earths wide now. So, it could get bigger, it could just disappear completely, we don't know. But spots like that are always popping up. And then sometimes the bands can actually disappear completely. Like this band could disappear and then just reappear a few months later. It happens all the time. Let me zoom back out a little bit. So I had kind of mentioned those moons, the 4 biggest ones. So Io, Europa, Ganymede, and Callisto. But the first 3, Io, Europa, and Ganymede, right here, they form a perfect ratio, 4:1. So that means that for every 1 orbit that Io makes, Europa makes 2, and Ganymede makes 4. So there was a group a while back that created a musical representation of the orbits of the first 3, and I think they actually did Callisto too, even though it's not perfect. But they sped up the orbits by 20 times, and then the beats formed a sustained harmony. So you can like listen to the sounds that the moons make. It's really cool. So if you just look up like Jupiter moons music or something like that, you'll be able to find it and listen to it. It's pretty cool. And then just below Jupiter, to the left a little bit, we have Saturn. So let me zoom in on Saturn. So Saturn's a little dimmer. As we see up here, it's got a magnitude of 0.15, but still super bright and super easy to spot. So Saturn is known for its rings, but actually all the other gas giants, Jupiter, Uranus, and Neptune, also have rings, but Saturn's are visible because it has ice covering them. So the ice is reflecting light from the sun. And the ice on the rings probably came from Enceladus, and that's this guy right here, one of Saturn's moons. So Enceladus is the shepherd moon. It's just like a big rocky ice ball. So the Cassini-Huygens mission, they orbited Saturn, and they took pictures of Enceladus, and they saw cryogeysers on Enceladus. So those cryogeysers are spewing 2 tons of material per minute, and so they think that it was that going out and onto Saturn's rings, covering them in ice. That's where that came from. And then we also have Titan somewhere around here. It's hiding somewhere. Oh, there we go. Here's Titan. Titan is the only other place we know of with stable liquid. So the Cassini-Huygens mission I was talking about earlier actually landed on it, and it's about -300 degrees there. So it's pretty cold. It's the 2nd largest moon in the solar system, and it's actually larger than Mercury, so it's pretty big. The atmosphere is just made up of different hydrocarbons, so it would probably smell like an oil refinery. Not super great. They have deep lakes of liquid methane, but we're not sure why there's so much methane, so it's one of the reasons why we need to study it. But it also has lots of other cool features like riverbeds and other features carved out by liquid. But back to the rings. So if you'll notice, there's like gaps in the rings, and that was probably just from moons orbiting through them. But the rings themselves aren't solid, they're just made up of a bunch of little rocks, and so they could be, you know, anywhere from the size of a grain of sand to the size of a house. So there's a huge range there. But if you were to go around this area, like the middle of the rings, if you ran 11 miles per hour non-stop, it would take you over 5 years to run around Saturn's rings. So just to give you a reference of the size, like it's just massive. But yeah, alright, Oliver, do we have any questions?
No, so the only comments we had, I guess there was some sort of audio issue in the beginning, but it looked like everything got sorted out. Otherwise, no comments.
Okay, cool. Alright, well, let me see. Alright, well, that's all I have for you guys, but be sure to come back next week. It's going to be somebody else, so like a different talk, and then we're also going to have trivia on Wednesday at 7 p.m., and there's going to be a prize for that. But thanks.